Hi everyone. So this week we're talking about logistic regression, and a point that I want to make about logistic regression before we get started is that it is the same process as linear regression. It's just that we're fitting a different type of curve to our data. So in linear regression, the type of curve that we are fitting is a very special kind of curve. It's a line. In logistic regression, we are fitting a logistic curve, which is shaped sort of like an S-curve. In both cases, again, we are just using a known pattern to try to fit we're fitting a known type of curve to our data. That's one of the reasons why these are explanatory. In the case where we choose a logistic regression over a linear regression is when our dependent variable is binary. So when it's true or false, basically we need to use, when our dependent variable is true or false, that's when we need to use a logistic regression. If it is continuous, as we looked at last week, then we can use a linear regression. So we'll talk about some of the special properties of, for example, the coefficients of logistic regressions. But again, I want to emphasize at the outset here that they are, in principle, the same thing, and we can do the same types of things with these different tools. So this is built off of a notebook that was developed by Jonathan Stray, and it is using the data set from the Who Gets a Ticket, Who Gets a Break Boston Globe investigation from 2001. Obviously, this is quite a while ago, but as you know at this point, one of the big challenges when we're doing any kind of predictive analysis is the fact that getting the data is sort of really the hard part. And the Boston Globe actually published their entire data set alongside their methodology with the story. And so that's a real boon to us because it lets us actually replicate their findings. So what we're going to do is obviously, load our requisite libraries, take a look at our data, and then start to do some analyses. And we'll start as we did last time, which is by doing some visualizations, looking at some histograms, some comparative histograms, and then doing a scatter plot, fitting our curve, and then understanding what that curve tells us about the data. So just to get started here, I'm obviously going to import my various libraries, and I have a CSV, which Jonathan actually modified just to include a header row. It is actually the exact same data set otherwise as what the Boston Globe provided. And we can get sort of a summary of this in looking at our, just looking at it through our Python notebook here. There is a complete methodology available, and I encourage you all, well, you should actually all have read that already. Let's make this markdown. But the methodology actually goes into not just the description of what is in the data set, but really, everything the Boston Globe did. So it's really worth looking at and reading through, of course, in order to understand what's going on. One thing that it includes violations other than speeding. Speeding is the one that we want to analyze and is actually the bulk of the data here. And so, then after that, we want to look at what are our possible independent variables of interest. And so type, ticket, or warning, right, is basically what addresses what we talk about here is this sort of denominator problem. So normally often one of the challenges that we face when we want to examine the fairness of the system, which is, in journalism, one of the things we're often looking for, is that we know who was affected, but we don't know much about the population that wasn't affected, right? So in this case, there was like a hot second, it was like 2 months, the Boston, I guess it was in the state of Massachusetts, when they were giving out speeding tickets, they would actually give out tickets or warnings, and it was the exact same form except for a checkbox, and the checkbox would indicate whether it was a ticket or a warning. So while we can't control for all of the drivers who never got stopped, what we can know is, of those who got stopped, which ones got tickets and which ones got warnings. Warnings, of course, have no effect on your driving license. They have no effect on your insurance rates. Speeding tickets, in both cases, do have an effect, right? So, we can't say we know there are this many drivers overall and this number of non-white drivers got stopped versus the number of white drivers that didn't get stopped, for example. But we can look at who was stopped and who got a warning versus who got a ticket. And so obviously some of the things that we think might be factors here are whether the driver was white or not, what the sex of the driver was, what the age of the driver was, something that seems reasonable, which is how far over the speed limit they were going, how many miles an hour over the speed limit they were going. And by doing a regression on this, again, we can start to understand whether we think there's something inappropriate happening. So the first thing we're going to do, the next thing we're going to do is we're going to narrow down the data set to look only at the speeding offenses, and then also just focus on the columns that interest us. So again, type is whether they got a ticket or a warning. Agency is actually really interesting as well. Agency is who gave the ticket or the warning. So that could be, in this case, it's either going to be a local police department, the Boston PD, so obviously the Boston City Police Department, or a state trooper. And we'll actually see a lot, there are some interesting patterns in the agency column as well. Sex, minority, which in our case we are coding as either, it says minority, but it's either white or non-white, is how they were clustered. The age of the driver, the raw miles per hour that they were driving, and the miles per hour over the speed limit that they were driving. And then in town is an interesting thing. This is basically because there is an idea that that cops tend to be easier, if you will, on local drivers. And so that's the reason why we're preserving that column. So we're going to start by doing a quick look at what proportion of our drivers are actually non-white in the first place. And you'll see that actually, the vast majority of our drivers are white, right? We've got about 80,000 white drivers. We've got about 13,000 minority drivers. And then we have fewer than 2,000 that the race is unspecified. And so we can just start to ask some really basic questions here, right? We can go ahead and look at, for example, what fraction, what percentage of citations were given to minorities. It's about 14%. And of course, we run into I actually have it as 13% here, but it's really closer to 14%. We have our classic question here, which is, is 14% a lot or a little? So this is another case where we run into the denominator problem. We could try to compare the minority population of the towns where the stops happened to the number of minority drivers who were stopped. But of course, even if we have like a census count, we don't know how many of them are drivers. We don't know what about people who are driving through. And so again, we're going to look at who gets a warning versus who gets a ticket, because we know that all of those drivers were stopped. So in this case, we're going to go ahead and drop the data, the rows where the race is unspecified. It's less than 2% of our data set, so I feel pretty comfortable doing this. That's something you always need to consider is, how much am I impacting the data overall. And then I just want to, again, sort of look at how many people are in each group now that I've removed those unknowns, right? And so when I say each group, what I mean is by white and non-white drivers, how many get tickets and how many of them got warnings, okay? So, we can see it looks roughly even for white drivers. It looks a little less even for minority drivers. And so we can create a nice little crosstab here that's going to sort of show it to us in table format, and probably even easier for us to view is actually to look at it as a graph, right? And finally, if we do these as percentages, this is going to get an even clearer picture. So, we can see that the relative difference seems to be higher for non-white drivers than for white drivers, but let's just check. So we can see here that about 60% of minority drivers are getting tickets, whereas only about 50% of white drivers are getting tickets. So more even in the case of white drivers than in the case of minority drivers. So what we're seeing is that even though we have non-white drivers making up a much smaller proportion of the people who are stopped in any case, their ticketing rate appears to be higher. And so again, we can do another visualization that gives us sort of a view on this. And this is just a histogram. So again, here we're just visualizing these two numbers, and it looks like there's about a 10% difference. The question is this significant? You know, we can see, you know, we want to avoid our Simpson's paradox possibilities here. We know that possibly it's race that is affecting this, but maybe it's something else, right? We have a number of other plausible factors that could be influencing the rate at which people are being given tickets. And so we want to try to start to sort those out and make sure that we're not confusing the issue. So the way that we're going to do this for starters, just to give ourselves, you know, something to work with, is we're going to start by looking at miles per hour over, right? So miles per hour over is something that seems reasonable. It's a little bit like age in our disabilities discrimination example, where, you know, the idea that because you're older you need a greater volume of support is reasonable, because, you know, if you're a young kid, presumably you're living at home, you're not paying rent, you're not doing all of these other things that somebody who is, you know, over the age of 21 might be doing. And if you're even older than that, you might need additional medical care, right? So in this case, miles per hour over would seem to be a reasonable, you know, almost should be the most influential factor, right? We would expect this to be, in a fare system, that this would be the main driver of the difference in whether you get a ticket or a warning. And we can look at miles per hour over. One thing that we want to do, obviously, is look at the underlying data. And we actually see right here that there are a bunch of zero values, 0 to 10, which actually is possible. I mean, 10 is possible. 0 does not feel possible. And so we want to make sure that we eliminate those ones where the speed isn't recorded, just to not have bad data in there, right? So again, we can do this because you know, we're confident that it's a pretty small part of the data. Now we can compare the histograms, right, the distributions of miles per hour over for white and non-white drivers to see if the distributions are different, right? So maybe the reason why more non-white drivers are getting tickets is because they're driving faster, right? So we can do a raw number histogram here, but it's actually kind of hard to see because the straight number of cases is so different. And so in that case, what we can do is actually use, we can actually do a different kind of histogram that's going to be a so-called density plot, and that is going to show us the percentage, and that will give us a much clearer sense, a much easier way to sort of normalize and compare these two. So now we can see that they actually match pretty well. So possibly, you know, our orange here is the our minority drivers. So it does seem like there's a little bit of a case where they might be driving a little bit faster. And, you know, we can't imagine that there are cases where let's say that pushes them, you know, here, like this is 20 miles per hour over. Maybe for some cops that's a cutoff, right? Like if you're more than 20 miles an hour over the speed limit, then you're definitely going to get a ticket, as opposed to a warning. So maybe that's something that's driving it. And so we can take a look at the averages. This looks like a reasonably normal distribution. So let's take a look at the average for each one. Pretty straightforward, right? We're going to do the mean of white drivers and the mean of non-white drivers, and we can see that it's about half a mile over. But again, you know, maybe it's pushing those drivers over some unspoken threshold that is causing them to get more tickets. So when we come back, what we're going to do is we're going to look at some of the other factors that might be contributing to this and see if we can find any cause for our pattern there.